So this is the Arduino program that I would have used to create a signal on pin 45 of the Arduino, and that's being fed into digital I/O1 on the My DAC. And the purpose of this is just to have a signal so that we can measure it. And a lot of this program, it's not critical to know it, but the two lines here are critical. So what I've done here is that I've set the period of the signal using output compare register 5A, and I've set the time high of the signal using output compare register 5B. Now the important thing to note here though is that some of these things that I've set up at the beginning tell me that the 16 megahertz clock on the Arduino, and that's the crystal oscillator that it uses, is being divided by 8. So 16 megahertz divided by 8 gives you 2 megahertz. And the period of a 2 megahertz signal is 0.5 microseconds. So that represents a value here of 8,000 clock cycles, or 8,000 clocks, times 0.5. And so 8,000 times 0.5 is 4,000 microseconds. This is 1,000 microseconds. So the period is 4,000 microseconds, which is 4 milliseconds. And the time high is 1,000 microseconds, which is 1 milliseconds. And that's what I'm going to be using for the program that I'm going to demo in just a second. All right, and this screen capture, all I wanted to show you was the measurement for the duty cycle, time high, time low for that signal. And let me add duty cycle. So I would go to measurements and time. And it should be positive duty cycle right there. So my positive duty cycle is 25%. My high pulse width is 1 millisecond, low pulse width 3 milliseconds. So you basically just want to compare what you're seeing on the picoscope with what you're seeing in the LabVIEW program. Make sure that you're using triggering here. You want to use auto trigger, simple edge, channel A, which is the blue channel, and a trigger level that's somewhere between the maximum and minimum. So about halfway, in this case, 2.6 volts. And the pre-trigger signal, probably the best place is at 10%. So basically what this does is moves where I start the trigger. So this is 10% of the signal. If I wanted to go to 20 or 30, okay, here's 30. So this is 10, 20, 30% into the screen. Kind of depends on the application of what you're trying to measure. I typically, quite often, will just use 10%. So that's where I'm going to leave it because I want to see what happens at the beginning. And the time base, well, this is 1 millisecond per division. I just want to show you what's not great. If I went to this, that's not great because it's hard to interpret the signal. So I'm going to go backwards. And maybe this is not great because I'm not getting the whole signal on that particular frame. So a millisecond is probably a good measurement. Let's go back to 1 millisecond. And that's okay. Let's see if 2 milliseconds, that's not bad either, but 1 probably is the best. And that's okay, but we don't have enough cycles. So I'll stick with 1 millisecond or 2 milliseconds. Either one of those is fine. Let's start off by putting some indicators on the screen. So just come maybe over here, and I'm going to right click numeric indicator. And I want to see the time high. So I'm going to write that in. I'm going to actually create 3 of these. So I highlight it, use the control key, and then give it some spacing because it's going to have a lot of screen space. And a couple more over here. We want to have a total of 6. Okay, and let's make all of them a little bit bigger. So to do that, I come over to here and click on size. And maybe let's make all of them at least 24. And let's say I want to make these 3 a little bit bigger and a different color because those are the important ones I'll want to see. So I go to slightly bigger font and let's change the color of all of these to red. and maybe the style to bold. And then I can even change the font if I wanted to. So let's say I come down to this font. Okay, so now I have those three. And maybe for these ones, just a little bit bigger. Okay, and so the next thing I need to do is for each of these three, which are going to represent, and let's change them right now, the time low, and then the period of the signal for this one. There we go. And this is going to represent the positive duty cycle in percent. And then the frequency. And then the period in ticks. And the ticks are 10 nanoseconds on the MyDAC. So now that I have all these, I might want to move them around a little bit. You have to make sure you're selecting the whole item here. So I'll put this here, the positive duty cycle down here. It's kind of your choice. You might want to make these boxes a little bit bigger, especially this clock ticks, because it might have a 6-digit number. This one not so big. Same thing up here. I'm going to give it a little bit more space. And then a little bit wider. Okay, the next setting is that we want to make sure that these three variables, and I'm going to highlight them, okay, time high, time low, period, that I want to make sure, and since they're all highlighted, these property changes will happen to all of them. Put them in SI notation. We want to have 2 digits of precision. Turn off that hide trailing 0, 2 digits of precision, and you can see how they're already set up here. And then once you do that, click OK. The period in ticks, well, the period is going to be an integer value. So let's go to display format. And it's going to be, we're just going to use floating point, digits of precision, and we're going to see a total of 6 values. It's going to be an integer, so I'm going to get rid of any fractional part. Just say OK, so that's all right. The frequency, obviously it's going to be a range of values, but what I want to do here is in display format, make sure it's floating point and maybe 1 digit of precision. And there we go. And the positive duty cycle, probably I could have selected both because we'd want the same thing here. Display format and floating point. And just 1 digit of precision will be fine. Okay, so I think that's everything I will need on the screen. Time high, time low, period, frequency, and so on. So I've got all of that done correctly. Now we are on to the block diagram. And what I want to do here is start off by right-clicking, going to structures, and creating a while loop. Every program basically should have a while loop, and make this as wide as you can on the page. And then over on the right hand side, we want to create a control. Over on the left hand side, we want to create an indicator to show us the iterations. So in here, let's type iterations. And the stop is fine where it is. The only slight issue here is that normally you want to have these wires going to the inputs. So basically just click on the wire and do clean up wire. And over here, same thing, clean up wire. And then the next step is we want to create the frames that we're going to use. And so to do that, right click, structures, and then look for flat sequence structure. And we're going to start off with one that's pretty small, and let's label the top here to visible items so we can tell it's flat sequence structure. And we need a total of these things that look like a film strip, but we want to have 6 in total. So to get more frames, you right click and do frame after. And since we need 6 of these, I'm going to do this a few times in a row. That's 3 so far. one more. Okay, and you can delete the frames if there were too many. And this is what's going to resize a frame. Now it's important to notice these little blue dots that appear over here because it tells you which frame you're resizing. So it's making that one a little bit bigger. And see, this one is connected over here. And so make sure that you look at the dots that you have over here. This one resizes this. So 1, 2, 3, 4. We're resizing this one. And then resizing this one. We can resize to fit the information that we need afterwards. So the first thing that I want to do is to measure the time high. So to do that, you right click, go to Measurement IO, DAC MX, and then DAC Assistant. So we'll put a DAC Assistant in here. And we want to measure, as I said, the time high. And I already have a signal applied to digital IO 0 on my DAC. It's coming from my Arduino. So I want to acquire a signal from the counter. And we want to measure pulse width. And it's going to be counter 0, since there is only one counter. And then click Finish. Now this is a very useful panel for testing and troubleshooting. So I can go to Run. And the time, in this case, the time high of my signal is 1 millisecond. If I wanted to see the time low, I would change this to falling. And that's correct for my particular signal. So I've got that all okay. The other thing that's important is to come down here and make sure this is one sample on demand. And again, I want to measure the time high, so I need to start with a rising edge. You may or may not have to change this. What this does is just tells you the range of the signal that we're going to be measuring. I'm measuring a 4 millisecond period at 1 millisecond time high, so I'm definitely within that range. If you need to change this, you can to be either ticks or seconds. For this one, I'm going to use seconds. So once you know that everything is okay, measured values okay, these settings are all okay, make sure it's one sample on demand. Let's stop this and then click OK. And what that does is set up the DAC assistant to measure the time high. If in that box you wanted to show that that was time high, you can double click on the DAC assistant and in here just change it to time high. It's kind of a reminder of what that's doing. And then I need to attach the indicator for time high. And I'm going to wire this to here. The other thing that will be important is you need a time delay in each of these loops for them to finish. And I'm just going to go to wait, and I'm going to make it 50 milliseconds. 50 to 100 is okay. Make it a constant of 50. And I think that's our first starting point. Let's make this frame a little bit not so large there. So that's good. And let's try it out. So I'm going to run this. We're going to see if we're going to measure time high, which is 1 millisecond for my signal. And we'll go to the front panel. And it is measuring it okay. If I wanted to make these windows a little bit wider, which I might have to if the value gets a little bit bigger, I can do that here. The other thing that's kind of interesting to do here is if I wanted to kind of group these together, I can do that by going to Decorations, and I'm going to put horizontal button box, just a way to look at the information. And I have to make sure that this is being sent to the background, so make sure this is highlighted with a marquee, and then say move to back, and now it groups this together. But notice I can move this box around and it's not moving that text. So the next thing to do is again group all of this together and say group, and now that I've done that, this moves together with all of the information. So now I'm kind of ready to measure. So notice that this box shows 1M, which represents milliseconds. I don't have anything for the period and time low yet. In this next part, we're going to complete all of the frames that we need. So one simple way to do that is to come over here, and we're going to group these together and then hit the Control key. and then move this into the next frame. Okay, and we've done that. Now, the only thing we have to be aware of is we actually have some indicators that we're using up there. This is a broken wire. To get rid of that, hit the Control key and the letter B, and it removes broken wires. So I want to put the time low into this frame, the period into this one, the duty cycle here, frequency. We seem to have something extra here, and that should be the period in ticks. We've got that. That's 1, 2, 3, 4, 5, 6, and we need to add one more. Okay, and I'm just going to say add frame after, and then widen this frame. This is going to be used to figure out actually the duty cycle. So we can delete this frame. Should be able to delete a frame, sorry. On the bottom, yeah, delete this frame. Okay, so we need to have a total of 6 frames. One for time high, time low, period, frequency, and maybe we'll switch this around. Put period in here, frequency in this box, and we're going to have to make this box a little wider. So make sure, so right now it's selecting the right hand side, so click in this box, and there we go. Now we can widen that a little bit. So we have all our screen indicators, and now we're going to move, we're just going to copy and paste one of these blocks into each. Okay, we don't need one for the last because we're going to do a math calculation, and we're going to copy this timer into each block. And there we go. And the next thing I'm going to do is change the labeling of the DAC assistant. So this is going to be our time low. This is going to be the period. Self-documenting. This is going to be frequency. And this is going to be, what do we have here? What are we missing? So the period in ticks. Okay, so we have all of that. So time high, time low, period, frequency, period in ticks, and this is going to be a calculation. And we can either do this one of two ways, but we'll look at that at the end. So the first thing to do is we've got this one all set up, okay? Let's wire the indicators to the data for each one of these. Okay, and this needs to move around. So this is on the left. Okay, and now we have everything that we need. In this part, we're going to calculate the positive duty cycle in two ways. The first way, we're just going to use some LabVIEW multiply and divide functions. And the second method, we're going to do it with a program using the formula node. So let's start off with the first method. So I'm just going to add a couple of local variables for time high and period. So to do that, you right click, structures, local variables. And I'm going to use 2 of them, but I want to change this from being a read or a write to a read. So that means the arrow is going to point outwards, and I can select that, use the Control key because I'm going to need 2 of them. And one of them is going to be the time high. So I select time high. The other is going to be the period. And then to figure out the duty cycle, it's going to be time high divided by period times 100. So for the math, I need to go to numeric, and I need a multiply, and I need a divide. Okay, so I'm going to put the divide here, multiply down here. I'm going to need a constant. because I want to multiply by 100. So create constant and put 100 there. Okay, I can move this out of the way a little bit and then connect this to the divide to time high divided by time low, or sorry, the period. And then the result of that gets connected to the positive duty cycle. So since my time high is 1 millisecond and my time low is 3 milliseconds, I should have a 25% duty cycle. So if I click on run and show front panel, it shows that my duty cycle is 25% with 1 digit of precision. And I'm just going to move the stop and the start to a more convenient place on the screen. They don't need to be so large. And I can even group these together under a different panel. So that's under decorations. And I'm going to use this one and put that there. That's good enough for now. So time high, time low, period, frequency, positive duty cycle, period, and ticks. I think we have everything that we need there. And I run it again just to make sure it works. Okay, and I'm always kind of checking that my iteration counter is moving along, which it is. So it's telling me that my loop is working. One final change. We're going to go back to the block diagram, and instead of doing the calculations for positive duty cycle using multiply and divide, just to get a little bit more practice, we're going to delete these items. Okay, and Control B to remove broken wires. And then we're maybe going to move this frame over a little bit to give us a tiny bit more space. And then in here, we're going to go to Structures, Formula Node, and we're going to create a formula node to write a program. And then click on line numbers so that we have line numbers and a label. You can even put a label here just to tell it to, well, we don't need one there. So now we have a program, and I think it's only going to be one line, but we have to add some inputs to here. And these are the variables that we'll use within the program. So I need to add an input. I'm just going to abbreviate it as TH, and this one as another input, just period. And it's okay if you use the same name. Then I'm going to attach this to the local variable, this one to the local variable, and then I'm just going to write an equation that the duty cycle, I need an output variable, so right click, add an output, call it DC for duty cycle, and the duty cycle is going to be equal to the time high. You have to use the same case, time high divided by the period, and then times 100 to get it in percent. Okay, and then notice up here it's telling us that we have an error, and that's because I haven't put the semicolon. So add the semicolon, the error goes away. We need to connect the indicator to that output, and then we'll test this out. Okay, and we still get 25% duty cycle, the same method as before. So coming back into here, this time I used a formula node. If I need a little bit more space, I can move this down over here. It's probably a good idea to put a 50 millisecond delay over here, but I don't think it's needed, but I'll add it. So to actually execute this loop, it takes 1, 2, 3, 4, 5, 6 times 50 milliseconds, about 300 milliseconds. So every 300 milliseconds, you're getting new data. Let's just try this one more time. Window, show front panel. So this is everything that's required to do that part of the lab where we're measuring time high, time low, period, frequency, positive duty cycle, and clock ticks. Okay, if I wanted to add my name on this screen, it's just right click, decorations, label, and I'm just going to put my name and the date. It's November 16th. Okay. And if I wanted to copy that, just make sure you have the handle here, the control key. And here I'm just going to put the one tick is equal to 10 nanoseconds on the MyDAC. Right, so in this case it would be 4 milliseconds divided by 10 nanoseconds is 400,000. And if I wanted to make this a little bit bigger, I just have the marquee, and the marquee is this scrolling dashed line around what you're trying to change. And I can go a little bit bigger in text size, and I can change the color, or even if I want it to be italic. And there you go. So that's pretty much it for that particular example. Now we are going to modify the DAC assistance that we cut and paste from this original one, because we have to make some changes here. And just a reminder, the signal that we were measuring is already applied to digital IO0, so we can do some testing. And it's 1 millisecond high, 3 millisecond low. So that's a period of 4 milliseconds and a frequency of 250 hertz. So let's start making some of these changes. So we'll come over to this one, which is supposed to be time low, but it's really just a copy and paste of time high. So I know it's a time high because it's pulse width and we start on a rising edge. But I'm going to change that to a falling edge. And as I'd mentioned, my time low should be 3 milliseconds. So I'm going to measure that. And you can see right here, it is 3 milliseconds. So it's doing everything that I want. It's one sample on demand. We'll stop this. We'll move on to the next, which is the period. We'll wait for that to finish. Open up the period. And in my case, the period should be 4 milliseconds. So it's not pulse width this time, so delete that channel setting. And then we're going to add a new one, period. And it's connected to counter 0 of MyDAC 1. Okay. Just make sure that the input range here matches what you're trying to measure. In my case, I'm measuring 1 millisecond, so it's well within that range. What's happening here is that the MyDAC will automatically choose the divide ratio based on the minimum and maximum settings that you've placed there. So if I want to measure my period, which should be 4 milliseconds, I can come up here and just verify that. That is okay. So stop that and then click OK. So that's measured the period. Now, since we're learning about counters and timers, this last one is to measure the period and ticks. And I think I have the names wrong here, so I'll just maybe cut this wire and change things around. There are multiple ways of doing this, but this is what I'm going to do. I'm going to put frequency in here, that over here, and so on, and just wire this up. But now I have to change this to period and ticks, so double click. And then we're going to measure the period. So get rid of that because that was the copy and paste. And period. Counter 0 of MyDAC 1. And then instead of using scaled units of seconds, we're going to do it in ticks. Now a tick is equal to 10 nanoseconds on the MyDAC because that is 1 over the 100 megahertz, the clock frequency of the MyDAC. And that's the smallest unit we can work with. So what we're going to do is measure how many clock cycles occur during one period of our signal. And since our signal is 4 milliseconds divided by the period of our MyDAC clock, which is 10 nanoseconds, should give us 400,000. So everything is set up correctly here. I'm measuring period. I'm doing it in ticks. Let's just test it out. And I'm getting 400,000, just what I expected. So select OK. It configures that. One last one to do is frequency. I'm going to do Control B to get rid of broken wires, which I just did there. I'm going to measure the frequency. Maybe move this frame over a little bit because I need a lot of space in the last frame. I can move everything over that way. And even I could, in here, I can select time low, move that over, make that frame even smaller, drag the timers. So the last frame is the one that takes a bit more space, but I still have to change the frequency. And so I'm done. Double click. And again, we're deleting pulse width and adding frequency to counter 0 of my DAC1. Now, since I have a period of, and we can look at hertz or ticks here, but we're going to go with hertz, and it should be 250 hertz. So run, and it is. Okay, so I'm just verifying that it works. Move on, select OK. So now we have time high, time low, period and ticks, and frequency. Let's go to the front panel and just make sure that is doing what we expect, and we have to be running. So there's our frequency with 1 digit of precision, our time high, low, and period with 2 digits of precision, and it's matching up with what I expected, 1 millisecond, 3, and 4.01. And we have an iteration counter and a stop button. So everything seems to be okay. We just need to add the positive duty cycle.